Okay, assalamu alaikum. I'm going to solve today one question related to conservation of energy. You can solve it with two ways, either conservation of energy or work energy theorem. So the question, I'm going to read it. We have 5 kilogram box is pulled 7 meter along incline. So this distance is 7 meter along the incline with constant force. The value of this constant force 150 parallel to the incline. The coefficient of kinetic friction mu k is 0.2. Find the change in kinetic energy. So I need delta K how much? And I know work energy theorem, work equals change in kinetic energy. Now to find W, we need, I know W is force times displacement cosine theta. We need to find all the forces acting on the object first. To find all the forces acting on the object, we have to draw free body diagram, all the forces acting on the object. So this is here the inclined surface. I have my object. First force down, I have Fg, gravity. Normal force perpendicular to the surface. Extend the normal force in this direction. I will have opposite to the normal force. It will be the component of the gravity or the weight of the object. So this angle, the angle of the incline theta, is the same as the angle between Fg and this one. So this will be Fg cosine theta, and here parallel to the inclined I have Fg sine theta. Don't forget we have the applied force F 150 and the direction of motion, direction of displacement up 7 meter. Now force, it could be positive, W work, it could be positive and negative or zero. I'm looking for positive and negative. Positive if F and displacement are in the same direction. That means the angle between them is zero. Which force can provide this option? The applied force, this one. So this one here, applied force, it will provide us with positive force. Which force will provide us with negative force if the angle is 180 degrees? That means F and displacement are in the opposite direction. Now, this is the direction of displacement. Opposite to the direction of displacement, I have Fg sine theta, this one, negative, and don't forget we have friction as well. Friction will be in the opposite direction of motion. So I have Fk as well will be negative. So let's rewrite now all the all my equation now. Let's just do them here. So my equation will be W, okay, net equals F times D, minus Fg sine theta times the displacement. This is the first force, which is negative, and I have another negative force, which is minus Fk, the friction force, times displacement. Now to calculate the value of the friction, Fk, it's mu k times Fn. And from the graph, normal force and Fg cosine theta, they're opposite and they're equal. So that means Fk will equal to mu k times Fg cosine theta. Now I'm going to substitute now with the value of Fk up. So W net will be Okay. W net will be, the value of F is 150 times 7 minus Fg. Fg is mass times free fall acceleration, so 5 times 9.81, it will be 49.05. This is the value of Fg. Sine 35 times displacement is 7 minus mu k. Mu k is 0.2. Fg is 49.05. Cosine 35 sine 35 times the displacement 7. Okay, so let's count these numbers. 150 times 7, it will be 1050 minus 49.05 sine 35 times 7, it will be 196.9 minus 0.2 times 49.05 cosine 35 times 7. If you plug all these numbers in your calculator, you should get 56.25. W net, the net work, will be 796.85 joule, and this will be the value of the change in kinetic energy. Now, to solve the same question using conservation of energy, I will give you a hint how to do it. Okay, but I will leave the method for you. Okay. Conservation of energy, at the beginning here, the object down here is moving, and I have applied force. That means work done because of this applied force plus the initial energy, since the object is moving, it will be kinetic energy, equals. At this position, at the top, the object is still moving, so I will have kinetic energy final, okay? At the maximum position, if it stops, it will be 0, plus I have height, which is this one, so it will be gravitational potential energy, plus since we have a friction, that means we have energy lost due to friction, and this will be W due to the friction force. If you arrange this equation, if we arrange it, you should get W equals kinetic energy initial, take it to the other side, it will be kinetic energy final minus kinetic energy initial. This will be the change in kinetic energy plus gravitational potential energy final plus work done due to the friction force. Now the tricky part here is how to calculate the gravitational potential energy. Gravitational potential energy is mgh, mass times gravity times the height. Now this height here, this distance, I have the angle 35 and I have this distance which is 7. So h will be from sine the angle theta, sine the angle theta will be opposite over adjacent. Opposite is h, adjacent is 7. So h will be 7 times sine theta. Okay. And W friction we calculated before, which will be force of the friction times displacement, and force of friction will be mu k times Fn. I'm going to leave this part for you. you finish it, you should get the same value as we did using work energy theorem.